Hello, my name is Ethan Lorisella, and today I'm going to talk about our large project. And so for our large project, we focused on some code that we had from evolutionary robotics class, and this code essentially simulates a robot and evolves its neural network. And this changes its weights of different motors, and measures how far it gets in this case. So we're trying to make a robot that can move to the left as much as possible. So why did we use this code? Well, so when you do run it on your own computer, I have a decent computer, but of course, whenever you do run this at larger and larger scales, it tends to eat up your CPU quite fast and wears out your computer, slows it down, yada yada. No one likes that. So we decided to take use of the large, the W3 servers, since I take it there pretty fast. And so there we can simulate all our generations of our robot, extract the output, print it out, and then be able to take those values and simulate on our own computer for very cheap cost in comparison. So this simulation, it involves a robot that has generally 2 block legs for now, and it'll just move forwards as best as it can. For this coding project, we use C++, and that was for mainly running some files. This is the robot CPP, and that's kind of the main hub after the HTML and PHP files work it out. So the PHP file runs our robot CPP, the robot CPP then runs our Python file search, which search then goes into and makes sure everything else runs fine. So the good part about this is that we can easily change this by either updating our robot, adding in more generations. It's very modular, which makes this quite nice. And so if I go into our website now, we make sure that user input is not an issue by having it just a select down. In the future, we plan to have it be 1 generation, 10, 100, maybe try 1,000, we'll see. I think we will probably continue this project as it will be very helpful for the class in itself. But so if I want to simulate 3 generations, so that's taking a robot, evolving it, figuring out what works, what doesn't, then it'll keep the things that it works well, alter a little bit some of the other values, and then retry. And so that's saying we're going to do this 3 times. And so this runs on the back end, and we get the fitness value, which that just determines how far or how well your robot did. So you want a high fitness value. So this is the parent, and then the child is the evolved one. But we have it be the parent, and this came out with some value. And so now I would be able to take these weights and plug them into my own robot on my desktop and be able to simulate it very, very easily. So it's quite nice for that. Here we have the CPP file, and that takes in the number of robots that you want from the arguments, which that comes from our PHP file. So here it copies over all the different files and adds in pyrosim, which that's used to simulate it. And then here we execute a shell command and send in generation options, which that, let's see, HTML, that's either valued 1, 2, or 3 right now. And so easily I can change one of these and have it be 100 generations, and makes it quite nice. Now, so let's see, let's go back here. This creates the executable, runs it. This runs, sends that value of number of generations over to the Python file. And as the Python file's running, it then writes its own fitness file text, where then we reopen it back in C++, and then print that output onto our website. So if we go into the search, this pretty much takes in the number of generations and simulates for X amount, and that's then used in some of the other code to keep the generations going. And then so we like to just show the best generation at the very end, and as in that's the best robot that it could come up with for those values. I guess I can. So I do want to show one video, which is just when this code runs, you can either choose to do it in direct or GUI mode. Direct, pretty much basic, is direct. It hides all the visuals. GUI, it'll show you all the visuals. And so from these values here, from the parent weights, I can then plug those into my base code. And in this case, I was simulating a quadruped. And so that when I'm running this base code, all in Python, but this is for another class, when it does run, you get a robot and he will walk around. And so those weighted values that we got before from the website determines how this robot will act, given some input values from sensors. And I think that's about it. And I can go over a bit of these files. So these are just like either connecting to a physics client, starting up your robot, running it. There's a lot of the back end. These are the sensor values. So this goes through all the sensors. You have your base robot, so a bunch of definitions preparing to sense, setting up a bunch of the links, but this was all some preset stuff for us. And so for our code, we focused on getting this and running all these other files. And that's worked out well. Okay, I think that's about it. Correct. And yeah, future work, updating the PHP file. We're not, both of us have never taken a PHP class, so learning a bit about that as we go. It would be nice also if we could open up a pop-up on the website that actually shows the simulated robot at the end, but that's out of my pay grade. But we'll see. And yeah, I think that's the basic idea. So it's a lot of just running the robot CPP, HTML, PHP files, and that all directs into this search, which then search creates a file, a fitness file, sends all those values to there, then from the CPP file, reads the fitness file, outputs the values to the website. Perfect. Okay, thank you.